What's up, Bearcats? Mr. Stephens is back. Some more FRQs for today. Bam. Hey, this FRQ is kind of mean. It's question 4 from 2014, and it starts really nice and friendly, and then part D hits, and it's ugly. So don't feel bad if part D beats you up a little bit, because it beats up most people. So here we go. I have a nice big fat table. I'm thinking, oh my gosh, I'm gonna give myself a rhyming sum, and then I don't, and I feel sad because those are easy, and this one's not so much. So here's basically what's happening in this problem. It's telling me there's a train, and my train is heading down a track that's east and west. So it's not really important whether it's going east or west, but it is going east or west. So if I think of what that means, here's my origin station. I'm heading in a direction. And rather than tell me the position of this train A, it's actually going to be the velocity on this map. So you can see it starts at stop, and then it starts going fast, and then it starts coming back towards the station because the velocity turns. So that velocity is going to be moving in a positive and negative direction, which means my train might be moving forward or backwards depending on where it is. It also says there's a function for A, there it is, and we don't really know what it is, it just calculates the numbers. So part A says, hey, find the average acceleration of the train. So remember, acceleration is going to be the slope of the velocity. So since it gave us the velocity, all I got to do is find the slope from 2 to 8. So I'm going to be able to use these two pieces of information to find the slope. So on the first part of your solution down here and on your scoring guidelines, you'll see that's all they did. Average acceleration is the slope. That's y2 minus y1 over x2 minus x1. So it says negative 120 minus 100 over 8 minus 2. So just like in algebra 1, we end up with negative 110 over 3. And these are going to be meters per minute divided by minutes. So we call those meters per minute squared. Please make sure you put that. A lot of times they'll say must have units. All right, part B. So part B is kind of gross. Part B is saying, hey, guess what? At t equals 2, train's position is 300 meters east. So it's going to give us this information here, which is our initial position. So remember, when we have falling objects or we have moving objects, we can calculate how far they travel if we integrate the velocity. But we also have to know where they started at. So that initial position, which is like S naught, that's the initial position we have to look at. So in our table, the initial position at time equals 2 is going to be 300. So what I should be able to do is, since this is velocity, I should be able to just integrate this information from here to here to figure out what that's going to look like. Oh wait, hold on. I skipped. Did I skip? I did. I totally skipped. I'm so sorry. I'm going to redo this whole thing. No, I can't. I'm not going to redo the whole thing. You know what? Sometimes you mess up. You got to go backwards. So I jumped to question C. I meant to do question B. It happens. Been a long day. All right. So let's go back to question B. Just going to jump back to question B. Then we'll hit question C later. Not a problem. All right. Sorry about that. So question B. Here we go. It says, does the data table support the conclusion that the train's velocity will be negative 100? At some point between 5 and 8. So here's 5 and here's 8. And it's asking me, is it possible that the velocity is going to be negative 100 between those two numbers? Well, of course it's going to have to be negative 100. The only way I can get from 40 to negative 120 is if I go across negative 100. So if I'm going to answer this question on an AP test, I have to cite some specific pieces of information. The first thing I have to say is 1, it's a differentiable function, says it up here. 2, it's continuous. I know, it's a train. It's continuous. And then I have to state, look, at 8, it is below 100, and at 5, it is above 100. Therefore, and I have to state this, the intermediate value theorem says the only way to get from 40 to negative 120 is to go through all of the numbers in between. Negative 100 is in between. So that's it. I get a point for each of those two things if I state them. All right. Rewind. back to part C. Hey, look, it's part C. So in part C, if you remember, initial position is 300, which means right here, S of 2 is actually 300. That's the initial position. So this other thing, that's the speed. So here we go. Let's see what they did, because it's probably going to make a lot of sense once we look at that under that context. So here we go. It says, if I want to find the position at 12, and that's what it's asking me for. It says, hey, what is the position at 12? Tell me the position at 12. And by the way, I need a trapezoidal sum. So I do get my Riemann sum with 3 sub-intervals. So I'm going to have 3 sub-intervals with my trapezoidal sum. That's gross. And I'm going from, well, I'm going to start at 2 and finish at 12. So you can see, here's my first sum, here's my second sum, and here's my third sum. So those are my 3 trapezoidal sums. So it says, hey, guess what? I'm going to start at 300, and then I'm going to add all of my Riemann sums from 2 to 12. So I'm going to start at 300 and then add my Riemann sums from 2 to 12. So 300 plus the integral from 2 to 12 of that table, and this is the Riemann sum. So, and then it just broke down the Riemann sum. It's like, dude, here we go. Okay, all these little subintervals are, it takes 3, it takes 3. These all go up by 3, plus 3, plus 3, plus 3. So those all go up by 3. So 3 times, and here's my trapezoid. Remember, trapezoid is base 1 plus base 2 divided by 2. So, base 1 plus base 2 divided by 2. Base 1 plus base 2 divided by 2. Base 1 plus base 2 divided by 2. Was that a 4? Oh my God, from 8 to 12 is a 4. Oh, I totally would have missed this. All right. Never happened. Never happened. This problem was perfect. Perfect. All right. So if I do all the math here, these add up to negative 450, which sounds great, but remember I did start at 300. So I get negative 450, negative 250. So I get a point for my expression. So I would want to make sure that I write this expression or even this expression, because this will get me 1 point immediately in the problem. I do get 1 point for my trapezoidal sum if it's all done correctly. And then if my final position at T12 is correct, I get my other point. All right, last chunk. Problem's killing me right now. All right, this one's super gross and ugly. I'm just going to get rid of that bottom paper. So here's the cool thing. It says, what if there's a second train and the second train actually leaves going north? So remember, train A was headed this way, and now train B is headed this way. And it's like, dude, I'm going to give you the velocity of train B. That table is the velocity of train A. And I want you to tell me what's happening between these two things right here. So if this is X and this is Y, we're going to call this Z. We have a right triangle with X and Y and Z. And the relationship between those three is going to be what? Well, Z squared equals X squared plus Y squared, Pythagorean theorem. So if that's true, if the positions are related like this, then when I find the derivative of this, I should be able to look at how fast each of those is changing. So I'm going to use something called implicit differentiation. And remember, if these are z's, if I find this in relation to t, I'm going to find dt of all of this. So when I find dt of all of that, I'm going to get 2z dz dt equals 2x dx dt plus 2y dy dt. And I should have all of these values already. So first of all, if x is 300, because remember, when is this happening? This is happening at time equals 2. So remember, at time equals 2, in this problem, at time equals 2, the initial value was 300. So that x is 300. The y is going to be 400, because it says right here, the train is 400 meters north at t equals 2. So that's the initial position for that. And it's a 3, 4, 5 right triangle, so z is going to be 500. So those are my values that I have. I can plug those into my equation right now, 500, 400, 500, 300, 400. All I need now is dx dt and dy dt. Well, guess what? Dx dt is straight out of my table. So dx dt says, hey, how fast am I moving? Wait, hold on, I can't see this yet. How fast am I moving in the x direction? If I look up at my table, right under my value right here at 2, it says the velocity at 2 is worth 100. So that's my dx dt right there. So over here I can put in, look at that, dx dt is going to be 100. Then I need dy dt. Dy dt I can get straight from my equation. They gave me this big giant formula for the second train. Velocity is at 2. So if I plug in a 2, I'm going to get, that's 2 and that's a 2. I get a total of, well, the velocity at 2 is worth negative 125. Or sorry, positive 125, so I put it in there. So now all of my information is filled out except for dz dt, which is what I'm looking for. So I'm going to solve this, divide by the 500, and I get 160 meters per minute. So I'm going to get 2 points for that information. And then all this other garbage is only worth 1 point. So if you got this far, this guy right here, that was worth 2. All right, add them up. Hope you did well. 4 points is our target. And we'll see you on the next problem.